Hello everyone, this is Kunal Mehta from Make Me Scientific, and in this video lecture we are going to solve the specimen paper of physics which is being uploaded by CISE and given by CISE for this academic year 2025-26. So as usual, the first question itself is MCQs. There are 15 MCQs, and the first MCQ says that if you have an anti-clockwise torque, suppose there is a torque or the moment of couple which turns an object in anti-clockwise direction, we take that as a positive torque. The clockwise torque is taken as negative. The kinetic energy depends upon position, no. Depends upon center of gravity, no. Depends upon displacement, no. Momentum is the right answer. That's due to the fact that kinetic energy is equal to p square upon 2m. Or you can also say, since p is equal to m into v, and if these two changes, of course the kinetic energy, that is half mv square, is also going to change. But this relationship is the direct one. Kinetic energy is equal to p square by 2m. Next question. During the power production in thermoelectric power station, which is coal based, the sequence is, so first of all we have coal, so we burn the coal, so heat energy we get. Now that heat energy is used to rotate the turbine, so we get the kinetic energy, and due to that kinetic energy electricity is produced, so finally the electrical energy. Which sequence? Heat to mechanical to chemical. Okay, by the way, what is inside this? We have chemical energy. So chemical energy, first of all, heat energy to chemical energy, chemical to kinetic, kinetic to electrical. But now let's see which order matches. So heat, mechanical, electrical. Yes, I think B option is the right answer. Heat, chemical, electrical. No, directly electrical, like it can't happen. Chemical to heat to light, this is incorrect. Heat to mechanical and then chemical, no, final should be electrical. So heat energy into mechanical energy of turbines, they have skipped this chemical energy part. Otherwise, in 4 step, chemical energy would come after heat energy. Anita used a single movable pulley to lift the bucket of water from a well. She lubricates the pulley. Which of the following is true regarding the performance? See, if you don't lubricate or if you lubricate, the velocity ratio remains the same. No change in the velocity ratio because the length of the rope in the pulley is constant. So what would change? Efficiency and mechanical advantage would change. That is due to the fact that load upon effort. Now load remains the same, right? But the effort required to lift the load and to overcome the friction if the pulley is rusted will become more, so the overall mechanical advantage will decrease in case of a rusted pulley. But if the pulley is lubricated, the mechanical advantage will increase, but not greater than 1. Okay, so velocity ratio remains unchanged and efficiency increases is the last option, which is correct. Mechanical advantage remains unchanged, wrong. Velocity ratio increases, wrong. It depends upon the design, and so velocity ratio can't increase. Mechanical advantage decreases and efficiency increase is again wrong, because efficiency is equal to MA upon VR. If MA would increase, then efficiency would also increase. So that means D option is the right answer. Inside the prism, dispersion of white light compared to blue light, red light slows down less. Red light, yes, if you look at the prism and if you pass the white light, we see that this is the red light and this one is the violet light and this is red. So if you look carefully, the deviation of red is less than the deviation of violet, and the speed of red velocity is greater than the that of the violet velocity. So slows down less and refracts more, no. Slows down more, that is incorrect. Red light has to slow down less and refracts less is the right answer. Slows down more but refract more is also incorrect, right? All right, now if we go ahead with question number 6, when objects are viewed through a rising heat of a campfire, this is due to the total internal reflection, right? They are simply talking about the mirage formation, something like mirage formation, that is due to EIR. Now, a convex lens has focal length of this. So If this is our convex lens and the focal length is 12 centimeter, that means 2f would be at 24 centimeters. Same here also, f and 2f. Now, the object is at a 20 centimeters distance. So the object is more towards 2f, but it is between f and 2f. So that means the image will be larger and beyond 2f on the other side. In order to obtain, okay, the blurred image is obtained 23 centimeters. See, now this distance is 24 centimeters, correct? Now, since you are keeping a screen here at 23 centimeters, that's why you're getting a blur image. So you should shift the screen away from the lens because the image is formed behind the 2f part. So if you shift the screen away from 2f or the lens, you would get the appropriate as well as the crystal clear image on the screen. Assertion: soldiers avoid firing the target in foggy weather conditions, of course, due to less visibility. That means A is correct, right? In foggy weather, light gets scattered by the tiny droplets, reducing visibility. That means they are talking about the scattering part. And yes, of course, due to the scattering, we can't see the things very properly. So this is also correct. So A and R both are true, as well as A is the correct explanation of the R is the correct explanation of A, correct? So let's move on to the 9th question. Two sound waves X and Y have same amplitude. That means loudness of X is equal to loudness of Y. And they have same wave pattern. Wave pattern means their waves exactly are of same shape. Something like this we can say. But their frequencies are 60 Hertz and 120 Hertz. So the one with less frequency will be less shrill and this is more shrill. So that means Y is shrill and X is grave. Loudness same, everything is same. Quality is also same because the waveform is also the same. So X is louder than Y, incorrect. X is different quality, wrong. X will be grave, Y will be shriller, that's correct. And of course, then A is the opposite, so it would be wrong. So that means B is our correct answer. Now the 10th one. 2 ohm, 3 ohm and 5 ohm resistors. So now if you look at these two, this is also a single resistance. I can also replace the above two because these two are in series. So this is also a 5 ohm resistance. Now what is going to happen? If some current I will come out of the battery, it will split up into two equal parts, I by 2 and same I by 2. That is due to the fact that both the resistances are same, so equal splitting will happen. So that means if the current passing through this is also I by 2, the same current will pass through 2 ohm resistance because both of them they are in series. So this is the correct answer. Whatever current enters in this wing, the same amount of current will also enter in this wing. So the current felt by 3 ohm resistor or 2 ohm resistor is same as that by 5 ohm resistance. According to the old convention, the earth wire was green in color, right? Now, in an ideal transformer, guys, you need to understand this well. Whatever transformer you may have, step up or step down, I must always take care in one thing, that power here, if it is 100 watt, then the same amount of power should be received on the other hand, which is not possible because there is a heat loss in the secondary and the primary coil and so on and so on and so forth. So we would expect the same amount of power. So that's why the power in the primary, if this is primary across which you are connecting the source, and this is the galvanometer where you are receiving the current. So we expect the same power. So power in the primary and the secondary coil must remain the same. So D option is the correct answer. Heat capacity of the body is the energy required to raise the temperature of any mass of the body by 1 degree Celsius. B option is the right answer. Then you have 14, the amount of heat required to melt a given mass at its melting point without rise in temperature is known as latent heat of fusion. Had it been vaporized, then we could have used latent heat of vaporization over here, but this fusion is the correct word, latent heat. Specific heat can't come because specific heats are involved only when there is a rise or fall in the temperature. So that means these three options are wrong. A nucleus, the 15th one, a nucleus of an atom has 146 neutrons and 95 protons. Now, if it emits alpha particle, that means 2 protons will be lost and 2 neutrons will be lost. That is due to the fact that alpha particle is a helium nuclide 2He4 and that is made up of 2 protons and 2 neutrons. So how many, what is the question? Let's completely read. How many protons and neutrons are now left? So that means out of 146, you will be having 144. So out of these two options, I will look. And then 93. So that means this option, C option, is the right answer. Question number 2. In question number 2, fill in the blanks. So mechanical advantage always greater than 1. It could come in class 1 levers, but in class 1 levers, you have all three possibilities. Ma equal to 1, Ma less than 1, Ma greater than 1. But of course, in class 1 levers, class 2 levers, you have mechanical advantage always greater than 1. For example, if I take an example of a wheelbarrow, right? If I take an example of a wheelbarrow like this, then here there is a lot of load, and this point is the fulcrum, this is the wheel, and here we apply the effort in the upward direction. So from the fulcrum to load, this distance is load arm and this distance is effort arm, and mechanical advantage is effort arm upon load arm for levers. So here you can clearly see that effort arm is greater than load arm. So in class 2 levers, you have load in between and mechanical advantage is always greater than 1. A boy uses GPS device. Now see, GPS uses microwave radiations for communication. Sometimes we feel that it uses radio waves, but the answer is microwaves. Microwaves, they cannot be detected. I mean, they cannot be scattered too much by the atmosphere. So that's why we use the microwaves. And they are very difficult to intercept also by the enemies. So microwaves, since they can go in the medium with very high speed, that is due to the speed of light, and with the same speed as that of the speed of light, but due to their larger wavelength, they get less scattered in the atmosphere. So now let's look at the next problem. The next problem says that unit of specific heat capacity. So Q is equal to mc delta T. Q is joule, so that is kg meter square upon second square. That is equal to kg. We don't know of C, and that to Kelvin, right? Kg gets cancelled. So that means this answer is the correct one. Meter square S minus 2 K minus 1. Threshold of hearing, guys. Now see, threshold of hearing is only possible when the intensity of the sound is 10 raised to minus 12 watt per meter square. Okay, it has got nothing to do with the frequency. Frequency of, when the babies are newborn, they can even hear the frequencies less than 20 hertz also sometimes, right? So the threshold of hearing is given by the intensity of sound, and this is the minimum intensity, and the loudness corresponding to that is 0 decibels. So 0 decibels is the threshold of hearing. Two copper wires can have different resistivity only if their temperatures are different, otherwise no, right? Because due to the temperature, the speed of electrons, the fast moving electrons increases, and then they collide with internal collisions increases, and thereby increasing the resistance, hence the resistivity. The reaction which is there in the sun is of course fusion reaction. Please write down the complete answer. I don't have space. Nuclear fusion. Okay. Now, the next question. Match the following. So, as given over here, nodding the head, this is clearly given in our textbook that the fulcrum is in the mid part. So, I would say that this is class 1 lever. And lifting the body weight. So the load is in between. So that is class 2 levers. So direct. Now see here, many students, they have confusion. If you look at our head, then there are muscles which are over here. Now those muscles, when you nod your head like this, those muscles contract and expand. So effort is over there. Now which part of the whole head does not move? So there are these internal bones or the part which are over here, they don't move. Whereas this is your whole mouth area where the load or the entire weight is there, right? So in order to lift this part's load, we need to apply the effort here, and the fulcrum is somewhere inside. So that is why the first lever of first type. Now if you look at this one, our whole body weight falls on the toe, mid part of the toe and the heel, mid part. And if you do this movement, fulcrum is the one which moves the least. The toes are the one which moves the least. If you do your legs like this, the toes are the ones which move the least, so they are the fulcrum. And then of course the effort is being provided by these muscles as well as the heel over here. So that's why class 1 and class 2 levers. Now the wave which we use it for echo, we use ultrasonic sound. Now why do we use ultrasonic sound waves? Because they can't be scattered. They can't be scattered too much. Now refer question number 3, refer to the diagram below. A lens is made of two materials. Lens is made up of two materials. Refractive indexes are shown. Now how many images will be seen? Now see guys, if you impart parallel rays, then if this is very high compared to mu2, then the focal length of the upper part, these rays will meet somewhere over here. But if this is less, the rays will meet somewhere apart. So two images will be formed. So I should only say that the number of refractive indices is same as the number of images. The other way to confirm is 1 upon f is mu minus 1, 1 upon r1 minus 1 upon r2. So r1 and r2 remains the same, but if there are two mu's, you will get two focal lengths. Two focal lengths, that means you will get two images, right? Like that. A glass lens always forms a virtual, erect, diminished image of an object kept in front of it. Identify the lens. So a glass lens is always forming virtual. So it has to be definitely concave lens. See, because in convex lens, what happens is only like this. If you keep the object between F and O, then and only then you get a virtual and direct image behind the object. But always it is only possible if you have a concave lens, and you can keep the object anywhere on the principal axis, anywhere. Suppose if you keep it over here, then also you will get a very small diminished and virtual image between F and O. So that's why, right? The given image displays 2 kilowatt-hour meter readings recorded at two distinct point of time. So earlier your meter reading was this, now it is like this, right? So that means what is the how much power or how much energy you have consumed. Let us subtract these two to get the answer. So it is 1567 minus 856. So 711 units. So 711 kilowatt hour you have used, which is equal to 711 units, because 1 unit is equal to 1 kilowatt hour, right? Assuming that 2000 watt air conditioner is the only one thing at your home, calculate the time interval in hours that between those two meter reading times. So they mean to say that suppose 856 was the reading, now this 2000 watt air conditioner, you are turning it on, and then it keeps on running and running till the electricity meter shows this reading. So I can say that energy used is equal to power into time. Energy used is equal to 700 kilo into watt into hour, which is equal to 2 kilowatt into some amount of time, right? Because see, this 2000 watt can be written as 2 kilowatt. Now simply kilowatt from here goes off. So you get time is equal to 711 divided by 2 hours, right? So that means this will be 711 divided by 2, that is 355.5 hours. So for these many hours, if you keep on running this AC 24/7, then you will get for these many hours, then you will get this much amount of uh, energy usage. Let's continue with the third part. Now here we have a regular pentagon and the center of gravity is at point O. Now they are saying which would be the most probable position if we attach a piece of clay at A. So that means if I attach a clay here at point A, the more massive part of uh, the whole pentagon would go down. The center of gravity is more towards the heavier portion. So earlier, if this was the point where the entire weight was concentrated, now it has to shift down and reach somewhere over here due to the heavy weight which we have added to point A. So X, of course, is the correct answer. Now, if the pentagon is cut along the line, so PQ, that means if I cut from here, earlier, this was the center of gravity, right? Now, we have removed the mass from here. So, the upper part compared to that of the O, upper part becomes more heavier. So, the center of gravity shifts towards Z part. So, here Z would be the correct answer. Now, the next question says that the solid of mass 60 gram, so solid of mass 60 gram placed at 100 degrees Celsius, so its own temperature is 100 degrees Celsius, and placed in 150 grams of water. So this is 150 grams of water at 20 degrees Celsius. Guys, I would suggest everybody to draw the diagram because it gives you a very clear picture of what could probably happen. The final temperature is 25 degrees Celsius, right? So that they have given. So that means this stone or the solid lowers its temperature from 100 to 25 degree and the water temperature goes up from 20 to 25 degree. So I should say according to principle of calorimetry, please write this. It carries 1 mark, this statement. Heat lost is equal to heat gained. Now, who is losing the heat energy? Of course, the mass. So, mc delta T. There is no melting taking place, so you don't worry about that. So, of the solid, then the temperature is also rising of the water. So, mc delta T of the water. So, that means mass is 60 grams. Specific heat capacity given? Not given? No, that is what we are supposed to find out, right? Oh, heat capacity is what we are supposed to find out. So C into delta T, 100, please understand that delta T has to be positive on both sides. So here 100 minus 25, so 75, that is equal to mass of water 150 grams, 4.2 joule per gram per degree Celsius, and rise in temperature is from 20 to 25, so 5. So this is what we are supposed to find, 60 into C, because heat capacity is equal to mass into specific heat capacity. So I am going to give the name as H. So that is equal to 75 ones are 75 twos are 5 twos are 10. 10 into 4.2 is 42. Now the unit, of course, H is equal to M into C, right? So this is kg and this is joule per kg degree Celsius. Kg gets cancelled. So joule per degree Celsius or joule per Kelvin is the right answer, but better write everything in SI unit because even this is given in SI unit, right? 1 degree rise in Kelvin is same as 1 degree rise in the Celsius. Next, fifth question. Now, we are given a diagram and this is a soft iron piece. Now here in place of B and A, if I use AC current, then also the current is going to create a magnetic field. Suppose this north and this south, then immediately this becomes south and this becomes north, because the poles will keep on flipping due to the nature of the alternating current which keeps on flipping. But anyways, guys, it is going to attract the pin. The pin doesn't only want to get attracted toward the north pole, it will get attracted to whichsoever pole you put in, because iron pin is finally going to attract to both poles of the magnet. So even if we use an AC source or a DC source, it does not matter, because AC current and DC current, they both produce magnetic field. So can attract an iron pin, this is very true statement, and justify your answer. That is due to the fact because both AC and DC produces magnetic field around it. That's why, right? Okay. Next, name the radiation that is emitted due to the decay of nucleus. Radiation is always gamma, right? But still, if you are even confused between alpha and beta, still they are giving us highest penetrating power. So this is gamma radiation, or symbol wise gamma, like this. Does the radiation change in mass number? Answer is no, because gamma is a form of energy. So whenever a nucleus releases energy, it comes to the ground state, and since energy is released, no particles are released. So if it is XZA, this would remain XZA, right? Only from the higher unstable state to stable state, it falls down. Okay. Now the advanced optical sensor in the air-to-air missile uses fiber optics, and which transmit signal with minimal loss. So which principle in physics we use? Of course, the answer is total internal reflection. So in optical fiber, you might be knowing that if the light enters like this, then here it will bend, and then it will keep on going like this and this forever, till it doesn't come out of the fiber, right? Two main conditions for TIR. Number one, the angle of incidence must be greater than critical angle. Number two, the ray should go from denser to rarer medium. Perfect. All right, now let's look at question number 4 of section B. Now here we are given a fish which is inside the water, and then we are actually looking it from inside, and we are seeing an inverted image of the fish on the top of the water. So you have to consider that you are inside the water, and from there you are looking at the top. So the image of the fish is vertically seen up, and this is due to the total internal reflection. I know many students get confused between the real height, apparent height, as well as TIR. But see, to observe the apparent height, right, you have to be outside. You are supposed to be outside, and from there you are supposed to look at the object, and that appears to be raised. Whereas here, the view is provided such that you are inside the water, and then from there you are looking at the top surface of the water, and the top surface behaves as a plane mirror, and you can see its inverted image, which is exactly shown over here. You can see that the lateral inversion also takes place. The fin of the fish over here is appearing over here upside down, correct? So that means this is only going to happen when you look yourself, and if the top part, the roof, is the plane mirror. So the surface behaves as a plane mirror. So this is TIR, total internal reflection, right? I would suggest all of you to write down the complete answer, not TIR, right? Okay. Now, the next question states that a double convex lens is placed inside two liquids. Now, this already has its refractive index mu1, and then mu3, and mu1 is greater than mu3, right? So that means in this case, the rays will converge to a certain position, and you will get the focus. So the lens refractive index is more than that of the refractive index of the surrounding. So in that case, this lens will give the converging action. as usual, right? Converging action as usual. Now, what happens when mu2 is greater than mu1? If the surrounding medium, that means this lens will give an opposite action. It will show the diverging action. Now, guys, see, I don't have time to explain this completely over here. So why don't you just click on the links below and find out the answer by yourself? Okay, so I have explained this part in greater details. Maybe you can check out those videos. So just remember that if the surrounding medium is going to be more denser, then this lenses give diverging actions, right? And see, I can try in another way. 1 upon f, that is equal to mu lens upon mu surroundings minus 1, and then 1 upon r1 minus 1 upon r2. Of course, we are not supposed to look at this part. See, this is known as lens maker's formula. Now, if you look carefully, mu lens is less, this is less, and this is large. So this number is going to be less than 1. So 1 upon focal length is going to be a negative number. So that means focal length is going to be negative number. And if focal length is negative, that means the lens is going to be concave. So that means this convex lens placed inside a denser liquid will give the action which is diverging in nature, and it will behave as a concave lens. But still, if you want to understand this in detail, then please check out the links in the description. Yeah, this question is based on the lateral shift, the apparent height and the real height. So there is a container in which we have oil, and then at the bottom you have an object like this, right? And then we are placing a ruler inside it. Now, this question is little bit ambiguous as per what I think, but anyways, right? See, the 0 centimeter of the scale is at the bottom, because some students may flip it and keep the 100 centimeters at the bottom. That is the only small confusion that I was having, right? So I think that is the only one place where students might get confused. So wet up to 25 centimeters mark. Okay. So that means I am supposed to keep 0 centimeter mark over here, and the 25 centimeter mark is over here. Of course, the scale has to be little more longer. So this is 25 centimeter mark. So this 25 centimeters will become HO, the depth. Correct? Now the refractive index is given as, okay, this is not oil, this is glycerine in the oil tank. So the refractive index is 1.25, and then we are looking into the tank and from the air, right? So Hi upon Ho is equal to mu2 upon mu1. This is the very easy formula that can be applied in all the cases. So Hi will become, so that means you will feel as if this comes up, and this distance will be referred as Hi. So mu2 is the refractive index of the medium where you have refracted ray. So what's going to happen, guys, that the ray of light will come like this. It will bend away from the normal, and then it will go inside the eye, right? So the incident ray is inside the glycerine, so this will become 1.25, and the refracted ray is in air, so this will become 1. So if you solve this particular part, so Hi upon Ho is 25 centimeters, that is equal to 1 upon 1.25. So Hi is equal to 25 divided by 1.25. So let me check what the answer is. 25 divided by 1.25, the answer turns out to be 20. So the apparent depth is 20 centimeters, and guys, remember that this is the depth, so it is measured from the top surface. Okay, so if the scientist lowers, the image of the object is at 20 centimeters, right? So somewhere over here, this mark is 20 centimeter mark. Okay, how would this length change if this liquid has refractive index more than this one? Of course, so this will go up, and this entire answer will go down, right? Because if the denominator increases, so Hi upon Hi is equal to 25 centimeters divided by this number, let's say 5, if I make it 5, then the HI becomes even more less, 5 centimeters. So from the top, the depth will become even more less. So the object's image will appear to be quite higher and higher towards you or towards the surface. A mixture of red, blue and green light passes through convex lens. Now guys, we know the lens maker's formula once again. So 1 upon F is equal to mu minus 1 upon R1 minus 1 upon R2. R1, R2 remains the same for all the three lenses, but refractive index for all the three colors are different. Now, refractive index of red color is equal to speed of light in air divided by speed of light in glass, right? So, velocity of red light is the highest, so the refractive index of the red color is going to be the lowest. So, highest would be of the blue, then green, and then the red will have least. And the red will have the least refractive index. Now, if we look at this lens maker formula, the focal length is inversely proportional to the refractive index. So the focal length of the red light is going to be the largest, followed by the green, and then followed by the blue color. So the red light is going to converge at the farthest distance. This will be the focal length for the red light. And the green would be, okay, let me change the marker pen. So green would be somewhere over here, like this. And then, so this point is the focal length of the green color and followed by the blue color, and the blue color will be at the last. So here, like this, of the blue color. Yeah. All right. Name the invisible radiation. We move on to the next question. So name the invisible radiation which can be studied with the help of quartz prism. We know that ultraviolet radiations, they are being absorbed by the glass, but they pass through the quartz prism. So these are UV rays, and they are used to check the purity of ghee as well as water purification. Water purification. That means they kill the germs inside the water, right? And to check the purity of ghee, oil, etc. Right? So that is the use. You can write down any. Name one type of radiation which has a wavelength greater. Okay, so you can write down infrared radiation. You can write down X. Oh, sorry, not X-rays, right? You can write down microwaves radiation, or you can also write down radio waves. So you can also write down any one of the visible light as well. Next, an object is placed at a distance of 24 centimeters from convex lens. So that means the object distance is negative. The focal length of the convex lens is always positive, 8 centimeters. Now, how can we understand this? Something like this. So this is the convex lens. Focus is at 8 centimeter. So 2f, this is 2f, this is f. This would be at 16 centimeters, which means the object distance is 24, so the object is beyond 2f. So you will get the image on the other side of the lens, and that too between f and 2f, and that too diminished in size, a little bit smaller than that of the object, and between f and 2f, right? So the answer must be between 8 and 24, and that too positive because it is on that side. So let's apply the lens formula. 1 upon f is 1 upon v minus 1 upon u. So 1 upon 8 is equal to 1 upon v minus 1 upon minus 24. So 1 upon 8 minus 1 upon 24, and this becomes plus, shifting on the other side. So this becomes 3 upon 24, that is 1 upon f, that is equal to 2 upon 24. So 1 upon f is equal to 1 upon 12. Sorry, I made a mistake. This is not f, this is v. So v is going to be plus 12 centimeters. That is the answer to the problem, and we got it right. The answer must be between the 8 as well as the 16. Okay. Calculate the distance of the image. We did it. Nature of the image is real and inverted. because it is formed on the other side. You must be very clear with the ray diagrams when you solve the numericals. Alright, so this is a cooling curve given. What does cooling curve mean? Cooling curve means that you have a gas that condenses back into liquid, that again changes into solid by the process of freezing. Okay, so over here at 150 degrees Celsius, you have a gas, then there is a state change happening because there is no change in the temperature. So over here you will have liquid, the temperature of liquid decreases, and the liquid now starts converting into solid, and now the temperature of the solid decreases. So here you will have gas plus liquid, here you will have only liquid, you will have liquid plus solid, and you will have only solid. Right, so this process is known as condensation, and this process is known as freezing. All right, guys. Okay, state the temperature at which the substance condenses. The answer is 150 degrees Celsius. That is the boiling point as well as the condensation point. Mention the temperature range in which the substance is in liquid state. So between 150 degree to 60 degree is the answer. Now let's discuss the C part. The amount of heat released when the substance is cooled by 10 degrees Celsius in the liquid state. So from here, the liquid state starts and it ends up over here. So it takes quite a long time. And that too from 150 degree to 60 degrees. And from here, the solid cools from 60 degree to 10 degree. That means in a very small time, 50 degree fall. Okay. So if I take a 10 degree fall here from, say, for example, from here to here, this time gap, let me call T1. Okay, and the same for 10 degree fall, here the time gap T2 is going to be very, very less. Now suppose, how do you cool a solid? So suppose how do you cool a liquid? So suppose this is the liquid and there is a machine that I'm going to put in, and this machine absorbs the heat energy from the water and cools down the water, right, and decreases the temperature. Suppose this machine has a power P. So the same machine is used here also, and the same machine is used here also, correct? But if you see the heat extracted in the liquid state, that is equal to power multiplied by time T1, and heat extracted by the same machine in the solid state is equal to power, same machine multiplied by time T2. Now, which time is smaller? So time T2 is smaller. And how do we know that? If you look at the slope of the graph over here in case of liquid is less, and in case of solid is more. So that means the solid cools down faster. All right, so less time. So that means Q in the solid is less than Q in the liquid. That is what we wanted to prove, and the answer is absolutely true. This is little bit of tricky question, but very good question it was. Right? Let's move on to the next part. In an experiment to measure the temperature of the Bunsen's burner, the lump of copper of mass this, so the mass of copper is given to us, that is 0.12 kg. And let me check, the specific heat capacity is given in grams. So I should convert this into 120 grams multiplied by 1000. In the same way, the copper is then transferred to a beaker which contains this much amount of water. Again, it is given in grams, and this mass of the water is given in kilograms. So this is 840 grams of water, correct? And the initial temperature of the water was 15 degree and final temperature was 35. So delta T for water is equal to 20 degree Celsius. Now, how do you need to understand this question? So suppose there is a water here. I should always ask the students to draw the diagram to gain the better understanding. So we have 840 grams of water and its initial temperature was 15 degrees Celsius. Then the moment you add that lump of copper here, the copper is going to sink, but I'm showing it on the top, right? And then the temperature of this copper initially was higher, and that we don't know, right? But it is way too higher than 35 degrees Celsius. Now what is going to happen? The heat energy is transferred from this copper into the water. So the copper starts cooling down and the water starts heating up. and the temperature of this water goes from 15 to 35 degrees Celsius, and this copper also cools down from T temperature to 35 degrees Celsius. So equilibrium temperature is 35. This is what it means. Correct? So now according to principle of calorimetry, heat lost is equal to heat gained. Please write the full sentence. According to principle, this carries 1 mark, principle of calorimetry. Heat lost is equal to heat gained. Who is losing heat? Copper. So mc delta T. So mass of the copper is 120 grams into 0.4 into delta T. That is always, you have to be careful that delta T has to be a positive number. So higher temperature minus 35. Now heat gained is by water. So 840 multiplied by 4.2 multiplied by delta T, that is 20. Right? Now this becomes 12 into, so this becomes 48, T minus 35, that becomes 84 into 42 into 20, correct? So T minus 35 is equal to 84 into 42 into 20 upon 48. So if I cancel this one, 2 tens are 2 24s, 24, so 2 again 12s are, then 2 21s are, then 3 4s are, 3 7s are, 4 1s are, 4 4, this cancels with 21. So 21 into 7, 21 into 7 into 10. So 7 ones are 7, 7 twos are 14, 1470, but this is T minus 35. So T minus 35 is equal to 1470. So final temperature, I mean initially the temperature of the copper was, I am going to add 35 over here. So 135, so 5 0, then 5 1, 1505 degrees Celsius. That is the final answer. Let's solve question number 6 now. Now here we have a metal rod AB whose length is 80 centimeters and balanced at 45 centimeter from end A. So from here, from end A, the pivot or the fulcrum is at 45 centimeter mark. That means it is balanced, and that too by looking at the diagram I can very well see that two same forces are actually balancing the scale, and that too not at the midpoint. Ideally it should be at the midpoint, but it is not, right? So which means that this rod is not a uniform rod. Its center of gravity does not lie exactly at the middle point. So now the question is, if there are two equal weights suspended, and you can see that this arm is longer and this arm is 45 centimeter mark, and this is 35 centimeters from the fulcrum. The 100-gram force which is at B is at 35 centimeters from the fulcrum. So by no means the clockwise and the anti-clockwise torque are going to be equal, and this can only happen if the center of gravity lies behind or right side of the fulcrum, let's say W, at some distance x from here, right? Because then and only then the clockwise torque which is being produced by the 100-gram force at B and the W collectively will be able to balance the anti-clockwise torque which is at which is due to the 100-gram force due to point A, right? So that means if you the question says that if you cut the scale from exactly the middle, which part would be heavier? Would it be AC or BC? So of course if you cut it from the middle portion, geometrically middle portion, the center of gravity is always towards the heavier part. So that means the BC is, the weight of BC is going to be heavier than the weight of the AC. So the reason is what you can say is that the clockwise torque and the anti-clockwise torque are not balancing if you don't consider the weight. So only balances if weight is, or I should say that center of gravity is on right hand side at any distance, right, from the fulcrum. So the logical reason is what I have given you, right? Let's move on to the next part, that is part number 2. For each of the following scenarios, work done is positive, negative, or 0. The person walks on the leveled road, the work done is going to be 0. That is due to the fact that when the person walks on the leveled road, the weight is downwards and the displacement is on the right hand side. So the angle is 90 degree. So work done is equal to FD cos 90. So answer is going to be 0. A person climbing the ladder, here when the person climbs up, his weight is downwards as well as, but the displacement is going to be upwards. So the angle is going to be, that is W is equal to mg. The angle between the force and the displacement is 180 degrees. So the work done is going to be negative. A car in a neutral gear is coming down the slope. All right, so let's draw a slope here. And instead of car, I'm just going to make a small ball, right? And the weight is vertically downwards, whereas the displacement is like this. And the angle between the weight and displacement is acute angle. So when you say that work done, that is equal to which force you are going to consider? The force of gravity, right? So that is the weight. So that is mg into displacement is in this direction and multiplied by the cos of the acute angle, and cos of acute angle is always positive. So here the work done is going to be positive. How come? You must remember something like this: all STC. So all angles, all the sine, cosine, tangents are positive in the first quadrant, which makes this our answer as positive. In second quadrant you have sine positive, in third quadrant tangent positive, and in the fourth quadrant you will have cosine positive, right? So that gives the answer to the problem. So the third one is going to be positive, right? Let's move on to the third part. All right, this question states that we have 4 points A, B, C, D, and they are on the hemisphere, and the diameter is 360 centimeters, which means that only the radius, which is from here to here or from here to here, right, that is 180 centimeters. All right, so I just want to write this down in meters, that is 1.8 meter. Okay, now this mass, there is an object whose mass is 500 grams, or I should say half kg or 0.5 kilograms, and that is going to roll down from the smooth surface, so no friction, so there is no loss in the energy. So when it was at the top, it was at rest. So that means the energy, the total energy at A was equal to kinetic energy of A plus potential energy at A, but there was no kinetic energy, right? And the total energy was only potential, which is equal to mgh. So that is equal to half into G is assumed to be, yeah, it's given in the question 10, right? So 10 meter per second square, and height above the ground is 1.8 meter. So this is 18 divided by 2, so 9 joule is the total energy at the top, right? So potential energy of A relative to B. Now B is at the ground, so that means the potential energy here is going to be 0, and the potential energy at the top is the total energy, which is 9 joule. So that is the answer to the first part, 9 joule. The speed at point B. So what happens is when the ball rolls down, the height above the ground decreases, so the entire potential energy gets converted into kinetic energy. So that means the total energy at point B, that is equal to kinetic energy at B plus potential energy at B, but the potential energy is 0. So the total energy, as per the law of conservation of energy, if there is no loss, total energy at A and B are the same. So total energy at A is 9 joule, that is equal to total energy at B, that is half into m into v square. So again, I should be making a point that this is 9, that is equal to half into mass is half again, and then v square, the velocity is what we need to find. So v square is equal to 9 4s are 36. So velocity is, everything is in SI unit. So 6 meters per second is the answer to the problem, 6 meter per second. Now we need to find the kinetic energy at point D. So now this is little bit, going to be a little bit lengthy. So be careful while you are attempting the question. So the total energy at point A has to be equal to total energy at point D, which is equal to potential energy at B plus kinetic energy at B. Sorry, D point, D. Now, we have both the energies at D point because D point is at some height above the ground. What height? So, the distance AD is R by 3. So, which makes this 2R by 3 distance above the ground, because we need height above the ground in order to find the potential energy. So, here we have 9 joules, right? And here potential energy is half into M again is half into H above the ground is 2 by 3 times of R again is radius, that is 1.8, plus kinetic energy is simply KD, and that is what we need to find out. So both the 2 and 2 gets cancelled. Then what do we have? Can we cancel it? Yes. Let's make this problem easier. So 9 2s are 18. So 18 is equal to 1.8 divided by 3 plus KD. All right. So did I make a mistake? Yes, of course I did. Yes, I didn't consider the kinetic energy part. So there is a small error from my side. I'm going to rectify it very quickly. So what do we have now? Yeah, we have 9 is equal to half. Now this 2 and 2 gets cancelled. So 9 is equal to 1.8 divided by 6 plus KD. So 6 ones are 6, 0.3. So the kinetic energy at point D is equal to 9 minus 0.3. So answer is going to be 8.7 joules. All right, let me check my calculations once again. Half into M into half into M into H above the ground is 2 by 3 times the radius 1.8 taken properly, 2 getting cancelled, 6 ones are 6 threes are, so 0.3. All right, I think I haven't made any mistake over here. So my answer is going to be 8.7 joules. Guys, sometimes error happens from the teachers also. So if you find any errors in the solution, please get back to me. Please post your valuable comments in the comment section. Okay, so in this question, we are supposed to draw the tackle and block system with velocity ratio 4. So here I have shown 4 pulleys and 2 in the tackle system, 2 in the block system. And we can see that there are 4 strands or 4 tensions that are supporting the load. If nothing is clarified, we are supposed to assume the effort in the downward direction. So as shown. So this is the labeled diagram, right? And this part, label diagram, means we are supposed to mark all the tensions, effort, as well as the tension here also. So this is the effort point, effort downwards, tension upwards. 4 tensions that are supporting the load show the direction of load downwards because it is the weight. Okay, now calculate the potential energy if this load goes up by a distance of 5 meter. We will consider G as 10. So the potential energy U is equal to mgh. So 100 kg F itself is the weight. I can also write down this as 1000 newtons because 100 kg F, when you converted that into Newton, 1 kg F is 10 Newton. So mg itself is 1000 and height is 5. So everything is in SI unit, Newton into meter. So 5000 Newton meter or 5000 joule is the answer to the B part. Now, a person is in front of a cliff. So in B part of the question or the second part of the question, there is a person who is standing here and he is firing the gun. So when he fires the gun, the sound goes and comes back, right? Let us consider this distance as x. So the sound travels a distance of 2x. And the echo is heard after 3 seconds. So 2x is equal to speed, that is 336, into time, that is 3. Right? So this becomes 2 1s are 2, 2 6s are 12, again 2 8s are 16. So 3 8s are 24, 2 carry, 3 6 are 18, 0 to carry, 3 1s are 3, 5. So 504 meter is the distance. Now, in the B part, the question says that he fires the gun again, but he is moving a certain distance from the cliff. So he is going towards the cliff or he is going far away from the cliff. Let's read the question again. So echo is heard 1.5 seconds later than the first one. So that means now it takes a longer time. So this person has moved a certain distance backwards. So now the person comes over here and this distance now becomes 504. So this is 504. And now let me consider this distance by which he has moved as x. Right? Or let me use another variable, otherwise a small confusion will happen. Now again the echo is heard. So now the total distance traveled is equal to 504 plus y, twice that distance, that is equal to 1.5 seconds later than the previous one. So 3 seconds earlier and 1.5. So now the total time is 4.5 times the speed is given 336. So if you solve this one, this is 1008 plus 2y is equal to 4.5 into 36. So if you solve this, you will get your answer y as 252 meters. That is the answer to the problem. So the person has to go 252 meters backwards, right, in order to hear the echo at 4.5 seconds again. In the third part, the mother has to push her daughter and she is swinging. So if she will not push, then what is going to happen? The oscillations are going to become damped. So ideally, when the oscillation happens something like this is the mean position, this is the extreme position. When this bob comes again back to the extreme position, you need to push again. Again, the bob goes and comes back to the this extreme position, you give a push. So the extreme position appears to be at point A. So the above picture, the swing goes from ABC. Which position out of ABC for the mother to give the constant periodic push? So the answer is A. Name the phenomenon involved. See, if you don't push, that means the damped oscillation is going to happen. And if you push periodically, and that is what is given, constant periodic push, then this becomes resonance. Actually a forced oscillation, but since the frequencies matches, that would be an example of forced resonance, forced oscillation, special case. On the basis of this example, how would you explain this phenomenon? See, at resonance, the external periodic force's frequency matches with the frequency of the swing or the swinging girl, right? And at that time, maximum energy transfer occurs. So always in resonance, maximum energy transfer occurs, and if the energy is maximum, energy is proportional to square of amplitude, so amplitudes will be maximum. Question number 8. Now, question number 8 states that there is a circuit for Ohm's law, and we are, instead of using a resistor, we are going to use a glass tube filled with mercury. Now see guys, this is tricky. Instead of resistor, if I use a metal rod, I am okay, because R is equal to rho L by A. So instead of that, they have just tried to confuse you by saying that we are filling a liquid mercury inside the glass tube. So what? Consider that as a rod of mercury, right? And in that case, the formula would be R is equal to rho L by A, correct? So now they are saying that there are two electrodes, E1 and E2 over here, and between them we have mercury. Okay, so it's clearly seen that there are two tubes. So let me go ahead and read. He records the reading of the ammeter and then calculates the resistance. Then he repeats tube 1 and tube 2. Here also we have mercury. But if you look at these two, right, here the cross-sectional area is more and the length is less. Here the cross-sectional area is less and the length is going to be more. So R is equal to rho L by A. So the length is very larger and area is smaller for 1. So the resistance of tube 1 is larger than the resistance of tube 2. Correct? Now, since they both are made up of the same material, mercury, so the resistivities are going to be the same. Correct? Now, let's see what they are asking. Neglect the internal resistance of this. Okay, you are supposed to compare. Guys, compare means the ratio. So that means R should be R1. Okay, I should write down at the top. So R1 upon R2, that is equal to rho L1 upon A1 multiplied by A2 upon rho L2. Now, since materials are the same, so this 2 gets cancelled. Now, what else is given to you? Oh no, simply comparison means they are asking us because the values are not given. So larger and smaller, we anyhow did it, right? So R1 is greater than R2. So we are supposed to compare the resistances by using the sign. So R1 is greater than R2. That is solved for the first part. Voltmeter readings. Now, I should be saying higher the resistance. Now the battery voltage remains the same. So V is equal to I times of R. Correct? Now, what's going to happen is since you are going to use the same battery, so the voltmeter will give the same reading. Because voltmeter, if they are both connected together, then the voltmeter reading across the larger resistance would be same. In series connection. In parallel connection, it will be the same for both. But I should be saying that if this is suppose a voltmeter battery and battery is of 10 volts, so the entire 10 volts is going to appear considering no internal resistance across the resistor. Now if you use this resistance or the another resistance, answer is going to be the same. So V1 is going to be equal to V2. Specific resistance, material are the same, so the same, right? So we have solved this problem. Let's go ahead. An appliance with the metal covering is rated at 2 kilowatt and 220 volts. So that means that power is equal to voltage times current. If these two are given, I can calculate the value of the safe current. Okay. Now there are 4 diagrams. Diagram 1 states that, okay, 8 ampere fuse is connected. And first of all, I should be saying that let's calculate the value of the safe current that is should be passing from all the 4 circuits. So here I should be using 2000 watt, and that is equal to 220 volts into I. So 2000 divided by, I should be saying 220, that is 9.09. So maximum safe current that should maximum current that this appliance can handle is 9.09 ampere. Oh my god, so you are using a fuse of 8 ampere, so that is going to blow away immediately. So I'm not even going to bother, or I will not never be bothered about the first 2 diagrams because they are very bad circuits, and this person who is just looking like a cockroach is going to get a huge shock because of the fact that the fuses, the fuses are going to get blown away. So this device is not at all going to work, right? So this person is not going to feel the shock, I'm sorry, because the fuses are going to blow off because the current is going to flow through it 9.09 ampere, and this fuse is of low rating, right? So these two fuses will allow the current to pass through them, right? But the thing is, guys, the problem is this doesn't have any earthing with the appliance. The earthing must be connected with the body of the appliance rather than the neutral. This is very safe part. This is live wire through which the current will come because the fuses are always connected with live wire. And from the neutral wire it goes off. The current should go back. And here the appliance should be connected with the earthing part. So that if there is any leakage, the current should get back to the earth before getting this cockroach type of man getting hurt, right? So I should be saying that S must be the safest circuit. Okay, because in the Q part, the earthing is connected to the appliance. Here the earthing is not connected to the appliance, but the problem is this appliance will not be in the working condition because of the low fuse rating, right? So write 2 reasons supported by the mathematical calculations. So the calculation is this one. So this is point number 1. right? That the maximum current, and the second one should be that the earthing is done properly, as earthing, earth wire should be connected to the metallic body, metallic part of the body, or outer covering of the body, or whatever you say, right? So it's done properly. All right, let's move ahead with the third part. The nichrome wire X, and the length and the cross sectional area are connected to 10 volt, and another nichrome wire Y, length 2L and area A by 2, connected to this one. Now again, this is the similar type of question. So compare the resistances. Resistance of A is equal to rho L by A. The resistance of B is rho, material is the same, but length is 2L, area is half, so A by 2. So this makes this as 4 rho L by A, right? So this is 4 times then the resistance of A. So if you say RA upon RB, the answer is going to be 1 by 4. So that is the answer to the problem. So X and Y, so answer is going to be 1:4. Calculate the power consumed by each wire. Now, see, the power consumed is going to be V square over R, or I square into R. Now, what else is given? We are supposed to compare, or compare the electrical power. So comparing means I square R or V square into R, are they connected? Nichrome wire X connected to 10 volt. Okay, they are connected to different volts as well, right? So power of A is V square over R. So this is 10 square over R, RA, and I should be saying power by B is equal to 20 square upon RB. All right. Now power A upon power B, that is equal to 100 upon RA, and this would be 4 times of RA upon 400, correct? So 100 ones are 100 fours are 4 getting cancelled, so answer is going to be 1:1, guys, right? So the second problem's answer is 1:1. Compare the masses of this wire. Now for the masses, you will need to find the density times volume. Okay, so that means the first one had length A, length L, and area A. So the volume of A is equal to AL. And for the volume of the B, the length of the wire is twice the length. So this is 2L, but area is A by 2. So again, the volume of the B is A times 2L, A by 2. Again, the volume remains the same. So the volume is same and the materials are same. So I think that the density is equal to mass upon volume, right? And the densities of two materials are the same because they are made up of the same material, and the volumes are also same. So the masses are also going to be the same. So if you ask me to compare the masses, answer stays the same, 1:1. Now we are supposed to say in the D part, true or false. Wire X and wire Y both show the same rise in temperature in the same time when heated. Okay, so when we give some, okay, here in this case, heat energy is I square times RT, or V square over RT. In the same time, we are supposed to prove, okay, or state whether true or false. Okay, so let me create some space for the calculations. All right, so let's say Q for A is equal to MC delta T. We are supposed heating the wire gets heated up, the masses are the same, specific heat capacities are the same, delta T. Now, provided we are giving the same amount of heat, right? So powers, all right, that is possible, yes. And how come? See, Q for B is equal to MC delta T. Now masses are same, specific heat capacities are the same because they are of the same material. Now this is power times the time, that is equal to mc delta t. Here again power of the B times time, mc delta t. So delta t of A would be equal to power of A into time upon mass into C. Now here delta T of the B is equal to power of the B times T upon M into C. Now M, C, power and time, all four quantities are same for both. So the rise in temperature is going to be the same. So this statement is true. Let's move on to question number 9. There are three bulbs which are power P1, P2 and P3, and they are connected in certain way that P3 glows the brightest. Now see guys, if power is V square over R, correct? Or you can use power is equal to I square times R. We will see which formulas work over here because they are asking which type of connection it is. It may be series connection or it may be a parallel connection. All three might be in series, all three might be in parallel. So guys, let's see. Now the highest power, the bulb with the highest power will have the lowest resistance for sure, right? Okay, now we'll have to look into it that whether this is a series connection or the parallel connection. So three bulbs, when they're, I think they should have given some more information, something like this, that when individually connected to a voltage source. So I'm considering that the voltage source is some battery, or even if it is AC source, that's going to be fine. Suppose 10 volts battery, and this is going to deliver the highest power, right? And that is P3. So which means that when individually connected to 10 volts bulb, the resistance of the R3 is going to be the least, correct? R3 least resistance. And then and only then you can get the highest power, okay? So that means resistances are in this order: R1 greater than R2 greater than R3, all right? So now if we connect them in series, let's connect all the three in series. And this is R1, R2, R3. And now if I connect them in series with the same individual, only 10 volt battery, then the same current will pass through all three. But this time, guys, which has the highest resistance? The bulb with the least power, and that is glowing. And in the question, it is the opposite. So definitely it's going to be a parallel connection, right? So think in both the ways that why it's not a series connection. That is what should click inside your minds, right? So this is the least resistance, this is the intermediate resistance, and this is the highest resistance. Okay, orders are R3, R2 and R1. And then if I give the same 10 volts battery across all of them, then the one with the least resistance will glow, because power is equal to V square over R is what we are going to use in parallel connection, and power is equal to I square into R is what we use in the series connection. Okay, so the one with the highest resistance glows the least, and the one with the the least resistance glows the brightest. So this is definitely a parallel connection. So I should write down parallel connection. The voltage across these are the equal. So V1 equal to V2 is equal to V3 because this is parallel connection. For which will the circuit function if one of the bulb fuses? Even if this fuses, then the other two will remain on because the current is going to pass through both of them because there is a closed circuit. So answer is yes. Let's move ahead. Now, this question states that there is an AC generator, and if the speed of the coil is doubled, and the graph is given, A means the highest voltage or maximum voltage, and B is the time period, capital T. Okay, so if you double the speed, the time period decreases by half. That is a very easy conclusion, because speed is double, the time decreases by half. So B becomes B by 2. And here, what is the effect on the physical quantity A? See guys, EMF is minus d phi by dt, rate of change of flux. So if the rate of change of flux, if you double the speed, the flux changes by double the amount. So the EMF will also become double. So the A will become double. It will become 2A. All right, now let's give the reason for the answer in B part. If the speed doubles, then the fan rotates uh, uh, 2 times. Suppose earlier the fan was rotating 1 time in 1 second. Now it is going to rotate 2 times in 1 second. So the EMF also increases, but the time is going to decrease, right? So I should be saying speed doubles, the fan covers double distance in, and this is the circular distance in the same time, or I should be saying for same distance in half the time. So that's why the time period becomes half, right? Okay. The third part is the graph of the neutron number against the proton number. Now, what are we supposed to say? A, B, C, D, E, 5 elements in the periodic table. These elements are A, B, C, D, E. Identify the radioactive element when C decays into element E. Identify the radioactive radiation, that means out of alpha, beta and gamma, when C changes into E. Okay, C is here and now it converts into E, in which the number of protons increases. So the the atomic number increases, and that is only possible in beta decay because atomic number increases by 1. So here I can very well see that if this is 85, this is 86, 87, 89, 90, then 91, 92, 90. Okay, this is the 90 has to be here. This is 91, 92, 93, 94, 95. So C has 93 and this E has 94. So atomic number increases by 1. What is the special name? Of course, these are isobars, because the same atomic number but mass number does not change, guys. How come? Because one neutron breaks up into proton and electron in the beta decay. So one neutron decreases but one proton increases, no change in the mass number, so they are known as isobars. If element C transforms into B, okay, that means atomic number decreases by 2, mass number decreases by 4. How will this ray behave? So of course this is an alpha particle which is going to be emitted. So in electric field, alpha, if this is positive, and if the alpha particle is being passed through it, which is positive, it will go towards the negative plate, right? That is what is the answer to the problem, because alpha particle being positive, it's going to bend towards the negative. So I should be writing it will bend towards the positive plate. So guys, it was my attempt to solve the paper in my own way. So please do comment your doubts if you have any, and thank you very much for your kind support and your valuable feedback till today. So keep on loving my channel, and thank you very much for watching the video.